Today, we're tackling one of the most common question types you'll see on exams like the SAT, ACT, and many competitive math tests: time and work problems. And let's be honest, most students see these questions and immediately start drowning in fractions. 1/10 of the job per day, 1/15 of the job per day, then a bunch of fraction addition, and suddenly a simple problem becomes a mess. But today, I'm going to show you a shortcut that makes many of these problems much faster. Instead of working with fractions, we'll use the least common multiple to turn the entire job into simple units of work. Once you see it, you'll never want to go back to the fraction method. First, let's remember one important idea. Time and efficiency are inversely related. The faster you work, the less time you need. So rather than focusing on time, we're going to focus on efficiency. That's the key to this method. Let's start with a classic example. Person A can finish a job in 10 days. Person B can finish the same job in 15 days. If they work together, how long will the job take? Most textbooks would immediately write 1/10 plus 1/15, but let's avoid fractions completely. Instead, find the LCM of 10 and 15. That's 30. So let's imagine the entire job consists of exactly 30 chairs. If person A builds 30 chairs in 10 days, their efficiency is 3 chairs per day. And if person B builds 30 chairs in 15 days, their efficiency is 2 chairs per day. Working together, they build 3 plus 2, which equals 5 chairs per day. Now divide the total work by the combined rate. 30 divided by 5 equals 6. So together, they finish the job in 6 days. No fractions required. Now let's try a harder version. This time, someone quits partway through the job. Person A can finish a job in 18 days. Person B can finish the same job in 15 days. Person B works for 10 days and then quits. How long will it take person A to finish the remaining work alone? Let's use the exact same strategy. The LCM of 18 and 15 is 90. So let's say the total job is 90 chairs. Person A's rate is 90 divided by 18, which equals 5 chairs per day. Person B's rate is 90 divided by 15, which equals 6 chairs per day. Now, we're told that person B works for 10 days. At 6 chairs per day, that means person B completes 10 times 6, or 60 chairs. Out of the total 90 chairs, 60 are finished. So there are 90 minus 60, which equals 30 chairs remaining. Now person A takes over alone. Their rate is 5 chairs per day. So the time needed is 30 divided by 5, which equals 6 days. Therefore, person A needs 6 more days to finish the job. Now, let's look at a very clever variation. Suppose 3 people are working together. Person A, person B, and person C can complete a job in 5 days. But if only person A and person B work together, the same job takes 9 days. How long would it take person C to complete the entire job alone? Once again, let's use our LCM shortcut. The LCM of 5 and 9 is 45. So let's imagine the entire project consists of 45 chairs. First, find the combined rate of A, B, and C. 45 divided by 5 equals 9. So together, they build 9 chairs per day. Now look at A and B alone. 45 divided by 9 equals 5. So A and B together build 5 chairs per day. Now comes the key observation. If all 3 people build 9 chairs per day, and A plus B account for 5 of those chairs, then the remaining work must be done by person C. 9 minus 5 equals 4. So person C's rate is 4 chairs per day. Now we simply ask, how long does it take one person building 4 chairs per day to complete 45 chairs? That's 45 divided by 4, which equals 45 over 4 days, or 11 1/4 days. Therefore, person C alone would need exactly 11 1/4 days to finish the entire job. What makes this method so powerful is that it transforms awkward fractions into simple counting. Instead of thinking about pieces of a job, you think about actual units of work. Chairs, bricks, boxes, pages, whatever you like. And suddenly, the calculations become much more intuitive. Don't forget to like the video, and I'll see you in the next lesson.